So Matt and Anna Killian are frequent flyers on Fast and Go Airlines. They often fly between two cities that are a distance of 1,680 miles apart. On one particular trip, they flew into the wind, and the trip took 4 hours. The return trip with the wind behind them only took 3 hours. Find the speed of the wind and the speed of the plane in still air. So this again is a completely different type of problem than ones that we've worked on previously. And this problem is going to use a special equation that hopefully some of you have learned before. And it says that distance is equal to rate, that's the speed, times the time. So the problem here is that we know the distance, that's 1,680, and it's going to be the same going and coming back. And we know the two times. We know that one of the times is 4 hours, and the second distance is the same, and the second time is 3 hours. So what we're missing here is the rate. Now the rate, however, is really made up of two things. You have the speed of the plane and you have the speed of the wind. When you're going, the plane is moving this way, but the wind is moving this way. And so that's going to slow down the plane. When you're coming back, the plane, let's say it the other way, the plane is moving that way, and the wind is moving that way, and what's going to happen is that you're going to speed up. So if we let x equal the speed of the plane, and we let y equal the speed of the wind, then we're going to be able to construct two equations. Now the key to this is that going, you have the speed of the plane minus the speed of the wind. Coming back, because the speed of the wind is going to reduce the speed of the plane. Coming back, you have the speed of the wind adding to the speed of the plane. So you're going to add those two together. And what we end up with then is an equation that's going to look like this. We have 1680 is equal to x plus y, and instead of saying x plus y, no, going, I should say, we're going to have x minus y, and it's going to take longer because the wind is against the speed of the plane. Coming back, we have 3 hours, and the speed is x plus y. All right, I hope that makes sense. And I put the, instead of writing rate times time, I made it time times rate. And just because it seems to work out better having the numbers on the outside on the left of the parentheses. So what I'm going to do with this, and I can do this actually in two different ways. I can multiply out to distribute, or I can each equation first get rid of the number that's in front by dividing both sides. And the first one by 4. And when I do that, bring in my calculator, I get 1680 divided by 4 is exactly 420. So that would give me the equation x minus y equals 420. I hope that makes sense, because these will cancel and this will cancel and give me 420 here. So for my second equation, I'm going to divide it both sides by 3, bringing in my calculator, I have 1680 divided by 3, and that gives me 560. So my second equation, x plus y, is equal to 560. So what is that? That's the speed of the plane minus the speed of the wind gives me a net speed of 420 miles per hour. The speed of the plane with the speed of the wind gives me a net speed of 560 miles per hour. Now if I were simply to add these two together, the y's are going to cancel out, and I'll get 2x is equal to, you can use your calculator to add those, it'll come out to be 980 divided by 2, and x will give me 490. So let's just double check that. So 980 divided by 2 is 490, and that is miles per hour. So what is that in terms of my original equation? That is the speed of the plane. Hopefully that's not the speed of the wind. That's more than tornado speed wind. And I can calculate then the speed of the wind using either one of my equations. And I'll just use the first one. So if I go to 490 minus y equals 420, subtract 490, subtract 490, and we get negative y is equal to negative 70. Dividing both sides or multiplying both sides by negative 1, we'll get y is equal to 70. And even that is a pretty rough wind there. So what we would need to do just to verify again that we had it right, we used the first equation, so we should use the second equation now with our x's and y's. If the x was 490, and then plus 70, and we do indeed get 560, so that checks, and we have the correct values here. X is equal to 490, that's the speed of the wind, and y is equal to 70, both are in miles per hour, and we have our final solution there. All right, we'll save this, stop this here, and again you can look at the printed solutions. You can also go back and replay the video. It's a very different type of problem, but hopefully you can understand what's going on. Our x and our y are referring to the speed of the plane and the speed of the wind. Going, the wind is against the motion of the plane, so we're going to have x minus y as the net speed. Coming back, the wind is blowing in the same direction as the motion of the plane, so we'll have x plus y as the net speed of the plane. And then we can set up our equations and solve for x and y. So that'll do it for this.